All right, so we learned how to solve quadratic equations that are in the standard form, ax squared plus bx plus c equals 0. We learned how to solve those by completing the square. Okay? Let's do that generally for any quadratic equation that's in this form. So just the general equation, ax squared plus bx plus c equals 0. Let's see if we can solve that. Okay? So step number 1, complete the square, is I'll divide both sides by a. So I get b over a x plus c over a. And then 0 divided by a is just 0. So I divided everything by a. That's the first step to completing the square. You want your leading coefficient to be 1. Okay, so I divided everything by a. All right, next step, I'm going to make room for the magic number. So x squared plus b over a x. Leave some room. Plus c over a equals 0. All right, now what is the magic number here? So remember, the recipe for finding the magic number is to take half of this coefficient in front of the x and square it. So I'm going to multiply b over a times 1/2, and then I'm going to square that. So let's come over here and do some scratch work. So my magic number is going to be half of b over a. So that's b over a times 1/2. And then I need to square that. And so I'm finding half of b over a and squaring it. So I get b times 1 is b. A times 2 is 2a. And I need to square that. If I square it, I'll get b squared on the top, and 2a times 2a is 4a squared. So my magic number is b squared over 4a squared. So I'm going to add b squared over 4a squared, and I'm going to subtract b squared over 4a squared. Okay, so I didn't really change anything. I added the number in, took it right back away. But now these first 3 terms will factor. So we'll do this really carefully. Okay, if I'm going to factor these first 3 terms, I'll need an x and an x. That'll give me x squared plus. So what do I need here and here to multiply to get b squared over 4a squared? Well, that would be b over 2a and b over 2a. Let's double check that. So I get x squared, b over 2ax, plus another b over 2ax. Let's see if that really adds up to be this. So if I have b over 2a plus b over 2a, that's going to be 2b over 2a. The 2's cancel, and it adds up to b over a. So again, x times x is x squared. X times b over 2a is b over 2ax, plus another b over 2ax gives me b over ax. Right. Okay, and then this times this will be b squared over 4a squared. So we have that factored correctly. Right, let's get rid of all of our scratch work so we have some more room. All right, we need to now simplify these 2. Okay, so let's do this very carefully. I have negative b squared over 4a squared plus c over a. All right, in order to add or subtract fractions, we need a common denominator. So if I want a common denominator, I'm going to need to multiply by 4 on the bottom. If I do it on the bottom, I have to do it on the top. I have a squared here, so I'm going to need another a. So multiply by a on the bottom, a on the top. So now I got 4a squared here, 4a squared here. I have a common denominator. So if I add these two together, I will get plus negative b squared plus 4ac. I'm going to switch around the a and the c, nothing wrong with that, over 4a squared. And that's all equal to 0. So negative b squared plus 4ac all over 4a squared. All right. Let's move on up here. And these two are the same, so I can write it as this squared. So we will have x plus b over 2a squared. And I'm going to go ahead and move this whole term, this whole thing, to the other side. So I have plus all of this. So if I subtract it from both sides, my signs will be different. So on this side of the equal sign, I will have b squared minus 4ac all over 4a squared. So this was minus b squared, now it's plus. This was plus, now it's minus. So I switch the signs. All right, next step, I want to take the square root of both sides. So x plus b over 2a equals plus or minus square root of b squared minus 4ac all over 4a squared. Make sure to be really careful. This entire fraction is underneath the radical sign. The whole fraction is underneath that square root. All right, solve for x. So I'm going to move the b over 2a to this side. So now I've got x equals negative b over 2a plus or minus. All right, remember, if you have the square root of a fraction, you can do the square root of the top over the square root of the bottom. So I will have the square root of b squared minus 4ac all over the square root of the bottom. So the square root of 4a squared. Well, we can simplify that. The square root of 4a squared is just 2a. Notice now that we have a common denominator. You probably noticed that as you were doing all of your completing square problems, you always ended up with this common denominator. All right, so common denominator, I can just leave that and add the two numerators together. So I will have negative b plus or minus the square root of b squared minus 4ac all over 2a. You probably recognize this. You've seen this before. You probably had to memorize it, and you know that it's a quadratic formula for solving quadratic equations or for finding the zeros or the roots of quadratic equations in this form. All right, so if we have any quadratic equation that's in this form, ax squared plus bx plus c is equal to 0, then we automatically now know what the solutions are. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You should memorize that. You should know how we got it and be able to get it yourself, and you should memorize it. All right, notice what would happen if a was 0. If a was equal to 0, then we would have a 0 for the denominator of this fraction. That would be bad. That would be undefined. Okay, so a cannot be 0. Notice if a was 0, this term would be gone, and that would not be a quadratic equation anymore. So in order for this to be a quadratic equation, your a can't be 0. And you can also see here that if a was 0, this whole thing would be undefined and make no sense anyway. All right, so your a can't be 0. All right, let's solve this equation. So this is in the form ax squared plus bx plus c is equal to 0. The first thing you should always check is see if the equation will factor, because that's easier. This one will factor, so let's do that. I'll have x, two numbers multiplied to get negative 21. Well, that might be plus 7 and minus 3. And 7 minus 3 add up to be 4, so we know we got it right. Okay. Once you've got it factored, if you have two numbers that multiply to give you 0, then either one of those numbers could be 0. So either x plus 7 is equal to 0, or x minus 3 is equal to 0. So either x equals negative 7, or x equals 3. All right, so we found the two solutions. Let's check one of those, make sure it really works. Let's put the 3 in. 3 squared is 9. 4 times 3 is 12. 12 plus 9 is 21. 21 minus 21 is 0. That really works. Let's put in the negative 7. That'll be 49 minus 28. 49 minus 28 is 21. 21 minus 21 is 0. All right, so we know we got it right. So our solutions we know are negative 7 and 3. Okay, this should be the way you solve this equation if I didn't tell you how to solve it. It factors really easily. That's really easy to do. But just for fun and practice, let's use the quadratic formula, because not all quadratic equations in that form will factor. Okay, so factoring won't always work. We might have to do it a different way. Completing the square is long and tedious. You don't want to do that unless somebody tells you to do it, or you just want to do it for fun. But now we have a formula that tells us exactly how to solve every quadratic equation that's in this form. All right, so we know that the solutions are this. All right, so my A is 1, my B is 4, and my C is negative 21. Right, so A is 1, B is 4, C is negative 21. So all I have to do is plug in the numbers. So x equals the opposite of B, so negative B. My B was 4, so that'll be negative 4, plus or minus the square root of B squared. B squared would be 16 minus 4 times A. My A is 1. C is negative 21. Make sure this line goes all the way across all of that. All over 2 times A. My A is 1. So we got that. All right, now we simplify. So I have negative 4 plus or minus square root. All right, 4 times 1 times 21. Or, excuse me, 4 times 1 times negative 21 is negative 84. So I have 16 minus negative 84. Okay, so a lot of people get confused with these negative signs. Okay, so be really careful here. This is 16 minus, and I'm going to cover up the rest of it, 4 times 1 times negative 21. So 4 times 1 times negative 21 is negative 84. 16 minus negative 84 is 16 plus 84. 16 plus 84 is 100 all over 2. The square root of 100 is 10 over 2. All right, so I have 4 plus 10. That's 14 over 2, or 4 minus 10, that's negative 6 over 2. If I simplify those, I get 7 or negative 3. Uh-oh. Those are backwards to what I have over here. How did I mess that up? Now, let's pause this and let me figure out how I screwed up. All right, so it was a good thing we factored this first and saw what the answer should be, because I made a silly mistake, thankfully, right at the end of this, so I don't have to fix too much. Obviously, I can't copy what I wrote. This is -4, so I need a negative right there. Silly mistake. All right, so I've got -4 plus 10. That's -4 plus 10 is +6/2. Right. -4 plus 10 is +6. -4 minus 10 is -14/2. So that gives me a -7 or a +3, and now it matches what I have over there. All right, let's try to solve this quadratic equation. So I have ax squared plus bx plus c equals 9. Okay, that's not good. And if we tried to factor this, we might get it factored or might not, but it would be equal to 9, and that wouldn't help us, because a number times a number equal to 9, we don't know anything about those numbers, or if we know very little about those numbers. Okay, it's got to be set equal to 0. And remember, our quadratic formula says that ax squared plus bx plus c has to be equal to 0. Can't be equal to anything else. So we've got to get a 0 over here in order for it to work. So I'm going to subtract 9 from both sides. Step number 1. That's 2 equals 0. All right, so now we got a couple of ways to try to solve this. We can try to factor it. We could complete the square, or we could use the quadratic formula. And let's see if it'll factor. So I need a 5x and an x. Okay. I got to get a -2. So let's go a 2 and a 1. So I get 5x squared, 5x and 2x. I can get a -3 out of that if I do it right. Let's put a minus and a plus there. Got some landscaping outside the window. All right, so we got 5x squared minus 5x plus 2x, that's -3x, and -2, so we got it factored right. And if I multiply two numbers together and the answer is 0, then either one of these numbers could be 0. So either 5x plus 2 is equal to 0, or x minus 1 is equal to 0. So if I solve this, I get x equals -2/5, or x equals 1. Just to check, we'll check this easy one, see if that really is a solution. If I put 1 into the equation, 5 times 1 squared, that's 5, minus 3, that's 2. 2 plus 7 really is 9. So we know we got at least that answer right. And if we got that one right, we probably got that one right. All right, so we know the solutions. I'm going to write those down up here. -2/5 and 1. Those are our solutions. Now, let's use the quadratic formula and see if we get the same thing. Okay, so I'll start with the second step where I've got it equal to 0. All right, so the quadratic formula says that x equals the opposite of b. Well, b is -3, so the opposite of b would be 3 plus or minus the square root of b squared. -3 squared is 9 minus 4 times a times c. Make sure your line goes all the way across there. My a is 5. My c is -2. All over 2 times a, which is 5. So all you got to do is fill in the blanks. All right, let's simplify that. 3 plus or minus the square root. All right, I have 9 minus 4 times 5 times -2. 4 times 5 is 20. 20 times -2 is -40. So I've got 9 minus -40. So that'll be 9 plus 40, so that'll be 49. All over 10. All right, let's simplify. 3 plus or minus. Square root of 49 is 7. 10. 3 plus 7 is 10 over 10. Or 3 minus 7 is negative 4 over 10. 10 over 10 is 1. Negative 4 over 10 is negative 2/5. And I hope that matches what we got over here. Hey, it does this time, so we got that right. All right, let's try one last example here. So I have 3x squared minus 6x plus 2 equals 0. All right. So let's use the quadratic formula to solve this. So x equals negative b, or the opposite of b. The opposite of negative 6 would be 6 plus or minus the square root of b squared. So that'll be 36 minus 4 times a. My a is 3 times c, which is 2, all over 2 times a, and my a is 3. Okay, so double check all that. X equals opposite of b, so that's 6, plus or minus the square root of b squared, that would be 36, minus 4 times a, which is 3, times c, which is 2, all over 2 times a, which is 3. Right, so we plugged in everything right. 6 plus or minus square root 36 minus, so I have 4 times 3 times 2. 4 times 3 is 12. 12 times 2 is 24. So I have 36 minus 24. 36 minus 24 is 12. All over 6. All right, let's simplify that. All right, square root of 12. We don't know exactly what that is, but we can simplify it a little bit. So 6 plus or minus square root. All right, 12 can be rewritten as 4 times 3. 6. Okay, why did I use 4 times 3? Well, 4 was the biggest perfect square that goes into 12. Okay, so 4 is a perfect square. It goes into 12. And it's the biggest perfect square that'll go into 12. So what I can do then is use a rule of radicals, or rule of square roots. I can break this apart into the square root of 4 times the square root of 3. So let's do that. 6. And now you see why we wanted to use a 4, because I know what the square root of 4 is. That's 2. So I have 6 plus or minus 2 times the square root of 3 all over 6. Now I can simplify just a little bit more. This 6, remember, has to go with both terms. So it has to go with the 6, plus or minus has to go with this other term. Okay, because if this was two fractions, I could have 6 over 6 plus or minus 2 times the square root of 3 over 6. It would be two different fractions. All right, so if I reduce 6 over 6, I'll get 1 plus or minus. If I reduce 2 over 6, I get 1/3. So that would be the square root of 3 over 3. Or 1/3 times the square root of 3. All right, so I'm going to write this just one more way. I mean, there's a lot of different ways we could write it. I'm going to keep the same denominator for both. So I'm going to simplify these by reducing each one of these by 2. Okay, so I'm going to divide by 2, 2, and 2. If I do that, I'll get 3 plus or minus 2 goes away, square root of 3, all over 3. So these two are the same, and you can see that if I made this one a 3 over 3, then I would have a common denominator of 3, and I would have 3 plus or minus the square root of 3. So either way you write that is fine.